Now that is air. But what is that? And how did it get here? What's with the air? Hey nose and/or mouth breathers, Trace here for D-News. There's a question going around Reddit Science right now that caught my eye. Where did Earth's atmosphere come from? And we started talking about it here at work and we weren't really sure either. Atmosphere literally means sphere of air, but air isn't really the right term either because that's just what we have here on Earth. Venus and Titan, they have atmospheres in that gases permanently cover their surface. In fact, a number of the bodies in our solar system have atmospheres, even the sun. The gases surrounding the celestial bodies are held suspended in space by the gravity of their host planets, which determines a lot about their makeup and potential to support human life. Our atmosphere came into being not long after the Earth cooled 4.6 billion years ago. As hydrogen and helium are extremely prevalent in the universe, chances are our atmosphere contained them too early on. The sun is 98% helium and hydrogen. However, as we were so close to the sun and pretty hot ourselves, much of those lighter, faster moving elements escaped Earth's gravity. Jupiter, Saturn, and Uranus got to keep theirs because they were so far away and so much more massive. Scientists believe as radioactive elements decayed and the Earth cooled, our remaining elements coalesced into solids, liquids, and gases. A 2009 paper published in the journal Science says at this point, the Earth was hit by many comets and meteors, bringing water vapor, krypton, xenon, and other atmospheric materials. Another older theory states that it was volcanoes that spewed that water vapor up into the sky. We'll leave it up to the researchers to decide which is true, but needless to say, at this point we know that there was water vapor, carbon dioxide, ammonia, methane, and neon that they think was already swirling over our hot crust. And yet another theory proposes that 4.5 billion years ago, when the proto-Earth was getting hit by asteroids, including a giant one that formed the moon, the neon in our atmosphere was completely blown off and a beneficial ratio of gases were left behind. From there, a secondary atmosphere began to form from those volcanic blasts or whatever, and the leftover heat inside the planet was released. Heavier elements like nitrogen split out, forming 78% of our atmosphere today, as well as the carbon dioxide and water. As the planet cooled, life began to form, and they did the rest. Note, I have not yet said oxygen, because there wasn't any. 2.7 billion years ago, when the first primitive life forms began to form, they lived anaerobically, or without air. These extremophiles digested sulfates for energy, completely ignoring the atmosphere altogether. Later, cyanobacteria, or blue-green algae, evolved to suck in carbon dioxide and output oxygen using photosynthesis. These guys are still around today. They use energy from the sun and carbon dioxide to produce oxygen. Eventually, and scientists know it happened but they're unclear how, there was so much oxygen in our air that it poisoned organisms that couldn't process it, causing a mass extinction. Microorganisms that could burn O2 survived, as did the cyanobacteria, and over millions of years, they added enough O2 to support the evolution of oxygen-sucking animals, which evolved into the living animals today, like you and me. As the planet continued to cool, the water vapor began to rain down, dissolving the CO2 gases into it and creating the oceans. The cyanobacteria spread, creating more and more oxygen. Oxygen is actually hard to find on most planets because it tends to react with everything. You know, it rusts metals, it burns easily, can make water. So how it got to a balance of 21% that we have today is still being studied. By final count, according to HowStuffWorks.com, our air is 78% nitrogen, 21% oxygen, 0.9% argon, and 0.03% carbon dioxide. The remaining 0.07% consists of water vapor, hydrogen, ozone, neon, helium, krypton, and xenon. Whew. And it's pretty nice. Do you have any other science questions? Ask them. We are always in the market for new topics. You can post your questions here in the comments or tweet them at us at DNews. And if you're loving the space stuff, come join us on July 30th at 4 p.m. Pacific for our Space Out. This month, we're hosting NASA scientists who work with the Mars rover Curiosity. We're going to hang out for a whole hour asking questions and digging into what they have been doing on Mars for the last year. RSVP with the link in the description down below to join July 30th at 4 p.m. Pacific time. Thanks for watching, everybody. I'm Trace, and y'all are great.